So the goal of this lesson is to explore the idea of if you have the graph of an original function, can you draw the graph of the derivative? And vice versa, if you have the graph of a derivative, can we graph the original function? And this is a topic that we talked about in some amount back in chapter 2, but I wanted to sort of bring it back here. So I'm going to look at one example of each of them, and we'll get to that now. My first example, given the following graph of y equals f of x, sketch a graph of y equals f prime of x. So in other words, they've given us the graph of a function, and they want us to give them the graph of the derivative. When you're going in this direction, often the best thing to do is to start with a few points where you very clearly already know the slope. Because remember, the whole point of the derivative is that it's supposed to be a function that gives the slopes of the original function. So looking at this original function that we have, like this point right here is an important one because I can tell the slope there is 0. So for my derivative graph, I'll put 0. Over here is another place where we have a 0 slope, 0 tangent. So I'll put a 0 there as well. And for everywhere else, I'm going to sort of just, for any given point, like for this point here, that slope seems to be about positive 1, so I'll put a point up here at positive 1. The slope over here really seems just barely less than 1, so I'll put, just barely less than 1. As they come along, this slope here might be positive 1/2 or so, so I can put positive 1/2 there. But the idea is, as you're going along, you can see that these slopes are getting smaller and smaller until they turn into 0. So we sort of get something like this going on. Right? As we continue on, this slope here seems to be a little bit negative, a little bit more negative, a little bit more negative. The most negative it seems to get is right here. In fact, that's another important point. This point right here, I hope you guys recognize as a point of inflection. And remember, we've talked before about the fact that a point of inflection should be a max or a min of the derivative graph. Right? So this point of inflection of f will correspond to the minimum of the derivative. Right? So the idea is, with these things becoming more and more negative, we're saying, well, this is a little bit negative, a little more negative, a little more negative, more negative, more negative. And you're sort of going to have something that's coming like this. Right? As we continue past this point, these slopes are all negative, but they're less and less negative, leading up to 0. So I've got less negative, less, less, leading up to that point. And then going past this point, we're a little bit positive, a little bit more positive, a little more positive, up to a maximum positiveness of about 1. So the same deal here. This will be more positive, more positive, more positive, like that. Your graphs are not going to be perfect. It's not always going to work out. But we can generally come up with something close. So the sort of steps that I had there, I know I didn't write them down. First, definitely plot the maximum and the minimum as zeros of your derivative, and then just sort of start walking across the function, looking at derivatives as you do them. So this was an example of me having an original function and drawing a derivative. We're now going to go in the other direction. So for this one, I'm giving you the graph of the derivative, and I want us to sketch a graph of the original function. And whenever they ask you to do this, they kind of have to give you this, some point on the original graph, because otherwise you really have no idea where to start, right? So given that g of 0 is 1, so my original function has this point on it, right? And so now, we've got a little bit of work to do, right? I again recommend that we sort of start with the maxes and mins, but here it's a little bit different. This is the derivative. So if this is the derivative, where will g of x have a max? Well, it should have a maximum wherever the derivative changes from positive to negative. Well, that happens right here. So it should have a maximum at about x equals, I don't know, looks like 1.6. Where will g of x have a minimum? G of x will have a minimum right here, where the derivative changes from negative to positive. So this is at, about x equals 4.4. So the idea is at 1.6, somewhere along this vertical line, we should have a maximum. Right? Where should that maximum be? Well, one thing we know is it should definitely be above this point. I mean, I have to go up to get there. And I know some of you are going to want to know, like, oh, well, how far up should the function go? And I think the best answer that I can give for that is that if this is the graph of the derivative, and what I'm about to say may be confusing, I'm going to spend more time on it in future days, but if this is the derivative, the amount that the original function should go up by is the area under the curve. So between 0 and 1.6, like we could sort of estimate, like what is this area here? And you might say, like, this is one whole box, this is another whole box, this is sort of a, these two together make a third box, this is maybe a half a box here. So it's sort of this idea that my original function should go between here and here, should go up by, I don't know, 3.5, maybe 4. And so you can sort of say, well, if here I am at 1, I'm almost going to run out of space here. My graph should probably go up to about there. Right? And it needs to level off when it gets there. Again, these graphs are not supposed to be perfect. I'm just doing what I can, right? So then I'm supposed to have a minimum over here at 4.4, right? So, I'm going to have a low point here somewhere, but how low? The idea is it should be roughly what this area is. So we could sort of say this is one box, two boxes, these together make a third, these two together make a fourth. Okay, so I'm going to come down about 4 units, right? So I'm going to say my minimum, let's see if that was 5. I suppose it'll be about here. And at this point I need to have leveled back off, right? So I'm going to sort of draw back down and then level it off to get there. And then beyond 4. So what's happening past here? Notice that these derivatives are all positive. So because those are all positive, we expect our original function to start going back up. So, and I know that was a really sort of quick example there, but I think the point I want to get at is it's stuff you guys already know. When the derivative is positive, your function will be increasing. When the derivative is negative, your function will be decreasing. When the derivative is positive, your function will be increasing. And at the very least, if you start out by identifying where your original function is supposed to have a max or a min, it should be a lot easier for us to sort of even plot estimates of those maxes and mins and then connect the pieces in between them. So that's all I have in this video in terms of graphing things. We'll have some practice with that in the homework, and hopefully it'll make sense.